Hello, everyone. Welcome to the reInvent virtual session about Amazon Linux workspaces for agile development. My name is Hassan, and I'm a senior product manager with Amazon WorkSpaces. In today's virtual session, we're going to cover quite a bit of ground in terms of understanding what Amazon Linux workspaces are, how enterprise customers are using Amazon Linux workspaces. We will then talk a little bit about how can you prepare to use Amazon Linux workspaces for your own developers. And we're going to talk about different type of developers that can use Amazon Linux workspaces. We will then go into a little bit more detail into building an understanding of how you can build customized images of workspaces that you can then deploy for different developer use cases. So this is going to give you the tools that you can take away from this session and rapidly deploy workspaces for your developers. And then finally, we will talk a little bit about how can you administer and manage Amazon Linux workspaces at scale. Obviously, when we are talking about deployment of Linux workspaces into enterprise, you need to be able to manage and administer them at scale. So let's get started. So first of all, let's get a little bit overview of Amazon Workspaces. Amazon Workspaces is a secure cloud desktop service provided by Amazon Web Services. The benefits of having a cloud desktop are obviously you get the benefit of pay as you go. So you only pay for what you use. And when you're not using your workspaces, you can either terminate them and your charging stops, or you can use auto stop workspaces, which stop automatically, and then your charging also stops. Obviously, the best benefit here is the benefit that you get with all of Amazon Web Services products, where you can simply deploy and manage your assets at scale. So instead of the existing method where you have to procure hardware devices like laptops and desktops, in this case, it's a few click buttons where you can effectively deploy cloud desktops and enable your users to use that cloud desktops through a multitude of different devices. For example, you can use Android, you can use iPad, and so on. And finally, with any cloud service, you can easily scale them. So if you have 2,000 users, for example, you can deploy 2,000 workspaces in a matter of days. You can basically wind them down if you don't need them at any time and stop your charging. So overall, it provides you a very secure cloud desktop service that is easily scalable, is performant, as well as only charges you for what you use. And one more important piece here is that because your actual desktop is sitting in the cloud, all of your data is also in that VPC. So your user is not actually getting that data downloaded to their client device. It's still sitting in your VPC in a very secure parameter. This is especially important when you're talking about developers who are freelancers or who are offshore developers who will be coding in your code base, and that code base is kind of proprietary or very highly secure for your company. So let's take a look at why Amazon Linux Workspaces is being used by different customers. So customers use Amazon Linux Workspaces primarily for developers and in their enterprise. And some of the other use cases that they use it for are web-based applications by using a simple web browser. So first of all, developers want to get started really early. So imagine a situation where you have new developers joining in, day out. Their IT equipment needs are generally a little bit more high than your regular employees because they need a set of tools, for example, Java, JDK installed in their desktop environment. They need some libraries related to their coding languages. They also would need some sort of IDEs like Eclipse and so on. So there's a lot of this preparation of the desktop that is required for developers that is a little bit more labor intensive than you would have for a regular employee. So what happens here is that when you're using Amazon Linux Workspaces, you create an image in the cloud in Amazon Workspaces service, and then that image is repeatable. You can launch as many workspaces from it as you would like. Unlike in the laptop or desktop world, where you have to physically go and image each and every laptop and desktop, this becomes very easy and easy to scale as well. The other benefit from it comes from the continuous management. So think about where your developers are leaving the company, or where there's an issue with their laptop or with their desktop. What do you need to do? You have to go and actually reclaim that physical hardware, or in cases where it requires some maintenance, you have to physically get that hardware and physically image it. While you're doing this physical imaging piece, your developers are not productive. They're not doing their work. So it's a productivity hit to your company, as well as a disruption for developers. So with Linux Workspaces, obviously you don't have that cycle, because you can immediately use some of the Workspaces features like rebuild to reimage your machine, where your root volume is reimaged with your image, and your user volume stays to what your user kind of modified it to. Or you can use the restore feature that Workspaces provide, which really takes both your root volume and user volume to the last healthy snapshot. And those snapshots are within 24 hours timeline. So really great experience for your users, because it takes less than a few minutes. So it's going to take, I think, less than 20 minutes or so for this whole process to be done. So you become ultimately your IT help desk and your IT operations become really agile, because you're not actually working on physical hardware anymore. And finally, these days, obviously, data security is very, very important. But at the same time, compliance is also a big requirement for a lot of companies. So we talk about HIPAA for healthcare industry. We talk about PCI for payment card industries. We have GDPR for Eurozone. So all of these compliance benefits are provided by Workspaces, and basically it enables you to readily use the service while staying compliant to all of these compliance mechanisms. And data security, we touched upon it a little bit earlier. Obviously, because the data is not actually being downloaded by the user to their local device, it stays secure in your VPC and in the cloud. So let's drill down a little bit. What is under the hood in Amazon Linux Workspaces? So first of all, Amazon Linux Workspaces are a OS feature layer for Amazon Workspaces. So Amazon Workspaces provides Windows 10 with BYOL. It also provides Windows Server 2016, as well as Amazon Linux desktops. So Amazon Linux is that operating system layer. If we go into a little bit deeper, what is that net benefit of using Amazon Linux with Workspaces? First of all, it's built for the cloud. What that means is that Amazon Linux was designed and built in AWS by the Amazon Linux 2 team. And it is highly efficient in resource usage and in streaming quality. So obviously you are streaming a desktop from the cloud to your end user. You need to be able to optimize this as much as possible and be able to have as minimum resource hit as possible. So Amazon Linux effectively provides you those benefits out of the box. Then, obviously, a lot of development these days happens inside containers, because you need kind of a consistent environment across the board, your developers. So these are Amazon Linux workspaces. They support Docker, so that a highly popular container that your developers can use to build consistent environments. The second biggest thing that is under the hood in Amazon Linux workspaces is that they are built to focus on enterprise. So all of the enterprise IT requirements, such as that the computer asset needs to be joined to their domain, in the form of an Active Directory. Similarly, that the Amazon Linux 2 kernel can be updated. So, the updates to the OS are continuously being done. And as well as that there's support for any software packages or any compilers that you're running on your operating system. So we talked a little bit about the updates here. The biggest problem that we saw in a lot of Linux deployments was that it's a very heavy lift for IT to actually go and continuously keep those machines updated. And generally, they just leave it to the developer to take that action. So obviously, it increases the attack surface area for your IT assets. So with Amazon Linux Workspaces, all of that is done by the Amazon Workspaces service. So that's why we call it fully managed service. And finally, all of the innovation that is delivered to Amazon Linux naturally flows into Amazon Linux Workspaces as well. These are some of the things that, we have modern desktop packages. We have Amazon Linux 2 core repository as well as extras repository. So in core, you will see a lot of, core packages such as Python and so on. And then in extras, you will see desktop packages, sort of the bleeding edge of the packages. So you'll see Mate, you'll see, LibreOffice and so on. So all of this is effectively being handed over to you in Amazon Linux Workspaces while we are fully managing this behind the scenes. So you don't have to take any action to achieve all of these benefits that we covered here. And the best part, all of these benefits are provided with no additional cost. So Amazon Linux Workspaces are priced at the same rate as our BYOL workspaces, where you are bringing your own Windows license. So there's no additional cost of using Amazon Linux on Workspaces. So let's elaborate a little bit about the developer use cases. So we talked a little bit about what Amazon Linux Workspaces are, what Amazon Workspaces does as a service. Let's drill down a little bit on what type of developer use cases you can use. Now, this is not an exhaustive list. Obviously, you can tweak your image to do exactly what your requirements are. These are some of the things that we saw in the market that are very common that our customers are using. Our customers are heavily using Amazon Linux Workspaces for .NET developer development. In those, you can see that there's a list of packages that you can kind of build and build custom bundles. So here, let's take a tiny segue to understand the concept of custom bundles. So every Amazon workspace is attached to a bundle. And a bundle is really a collection of hardware, software, as well as your operating system. And in terms of hardware, we are talking about what type of compute you have, what is the storage size of your machine, what's the RAM of your machine. In software, we are talking about exactly what is written here, where you have a set of applications that you have installed. And finally, the operating system, which in this case is Amazon Linux 2. So now that we have talked a little bit about custom bundles, let's elaborate on how we create these custom bundles. So a custom bundle can easily be created by you selecting the three components of custom bundle. You can select, compute along with memory. You select, the operating system, which in this case is Amazon Linux, and you basically launch a workspace. And once you launch the workspace, you can install any sort of packages and applications that you want in that workspace. And then you create a custom image from it, which is going to be attached to your custom bundle. Now what happens is that this custom bundle that you created can repeatedly be used to launch as many workspaces as you want or desire. So to kind of wrap our heads around it, if you create a .NET developer custom bundle, you can deliver this workspace with this custom application load to say 2,000 developers that are working on .NET, or 4,000 developers, or 10,000 developers. So it makes this process really, really easy that we discussed earlier. This is kind of that happening in action. So I'm not going to go into the details of each of these custom bundles. These are just for your reference that you can create a Java developer bundle or Go developer bundle or even Win32 developer custom bundle to enable your developers for the specific type of development they're doing. So let's talk a little bit about deployment. So now what we covered is what is the benefit of Amazon Linux Workspaces, how customers are using it in their enterprise workloads, and we discussed how you can build custom bundles for your developers who are working on different type of development trains. So let's get down into how can you deploy it for your IT. So first of all, obviously, you will have to prepare your networking and VPC. Being a fully managed service, that's really easy to do with Amazon Workspaces. The two key components here is that you have to establish your directory, which is the Active Directory. This is the Active Directory where your workspaces are going to be joined to. So that's the domain join step that we talked about earlier. And then on the other hand, you will select your subnets for your workspaces so that they can have those IP addresses. And then in the top piece of this diagram, you see a few gateways, which are streaming gateway, authentication gateway, and so on. These are part of the Amazon Workspaces service, so these are not the pieces that you're actively deploying. But they are effectively authenticating against your directory credentials. They are after the authentication is successful, they are creating that streaming channel to your user so that they can stream that desktop view, and so on. And then on the bottom left of the larger square here, you can see that there's the VPC. So this is the customer VPC. This is the VPC that you are planning for. And you can see that it's very lightweight. You just have to establish your subnets and determine the directory that the workspace is going to talk to. So it can populate users. It can authenticate against that directory for those user credentials and so on. So once you have that kind of understanding of that overall flow, let's talk about some of the best practices when you are doing a design of Amazon Workspaces VPC. So generally, we recommend that you have a separate VPC for Amazon Workspaces compared to your production code base or even beta code base. So it really becomes kind of your security parameter around workspaces being the desktops versus your other VPCs, which are serving different purposes like production applications, as well as your sandbox environment or test beds and so on. So one other thing that we generally recommend to customers is that for each of your separate workloads, you should create a separate AD connector. So kind of create somewhat of isolated environments from each other. And the benefit of this is, for example, you have full-time employees who are using Amazon Linux Workspaces, and then you have offshore developers who are also using Amazon Linux Workspaces. Both of them are doing development. Now, because the data has a parameter in the VPC layer, you clearly want to have a data delineation between your full-time employees and between your offshore developers or freelance, who are contractors, not necessarily your full-time employees. The effect of this will be that for your full-time employees, you might want to give them much more permissions and access grants to access different code base versus your contractors. You might want to restrict them to only certain servers or certain code bases or certain IT artifacts. So it's always a great practice to keep your user population kind of segregated on a per VPC basis. Then we also recommend for disaster recovery perspective to deploy them across two AZs, at least two AZs. That way, generally it doesn't happen. But in any case, there's an issue in any of the AZ. At least you will be able to keep your users productive by switching them over to the other AZ. Then for developer workloads specifically, some enterprise customers like to keep them in private subnets and not publicly, advertise the interfaces on the workspaces. Obviously, there's two mechanisms to do that. The main reason that a workspace will have a public subnet is because you want to give internet access to your user through that workspace. And in case of private subnets, that doesn't necessarily mean that you won't have internet access. It just means that the immediate interface on the workspace is going to be in the private subnet. But you can definitely use some sort of internet gateway to route all the private traffic from the workspace to that gateway. And then that gateway is able to access the internet. So in effect, your user doesn't have any different experience. They can still access internet, whether they're using public or they're using private subnets. The difference being that in private subnets, you have an additional gateway. And that really helps you control the flow of traffic. So if you want to restrict some websites, if you want to restrict certain networks or attacks, that provides you that control through that gateway. Obviously, in some cases, you will see that your developers might need public interfaces on the workspace, and it's totally okay to do that. It's just really dependent on what sort of controls you want to put in place for your workspaces. And then finally, whenever you're doing large deployments, it's always a best practice to plan for it. Frequently, what happens is that customers, they don't necessarily plan for a pilot stage for their large deployments, and that ends up biting them back later in the game. And the main reason for that is that you need to be able to test that your developers will have great experience. You need to be able to test that all of the workspaces are well integrated with your existing IT management tools, with your active domains, so your domain controller is easily reachable. There's no issue whenever a user is trying to log in. So all of these are mostly kind of test environments that you should certainly do in the pilot stage of a product or a project before you take it to a large-scale deployment and make it production. So it's always a good practice to do that. And here's a link if you want to go a little bit more detailed into some of our best practices. You can note this link down and take a look at it. So real quick, we can take a look at what Amazon WorkSpaces disk and network configuration is. So generally, all of Amazon WorkSpaces have two network interfaces. One is the management interface, which is what we call Ethernet 0 interface or ETH0. And we have a VPC interface, which is the Ethernet 1 or ETH1 interface. The ETH0 interface is where the management interface, where all of your streaming traffic is flowing. So this is the interface that Amazon WorkSpaces service uses to stream the traffic, as well as to deploy updates. We talked a little bit earlier about that all Amazon Linux workspaces are continuously updated as the updates are coming in. So this is the interface that we use to inject that update. And on the other hand, the VPC interface is the interface that is in your VPC. It's fully controlled by you. You can do whatever you like to do with that interface. How do you want to, restrict traffic, monitor traffic, and so on. Every workspace has two partitions. One partition is the operating system partition, or what we call root volumes, and the user partition, which is what we call user volumes. The operating system partition, as the name suggests, is the partition where you have all of your operating system, and the user partition is where you have all of your user files are going to be stored. So the effect or benefit of this model is that in case there's any issue with your operating system partition and your operating system gets corrupt, your user data is still safe. So that's the feature that we quickly touched upon earlier, where it's the rebuild feature where you basically throw away the operating system partition and reimage it from your fresh image, but your user partition is the one that is already in the last snapshot state within 24 hours. So let's talk a little bit more about the Amazon Linux Workspaces hardware options. We discussed earlier about custom bundles, and we discussed that hardware has different sort of compute and RAM configurations, as well as different partition sizes. So in case of partition sizes, each of the partition that we talked about earlier here is available in different sizes by default, but then you can also extend them each to 2 terabytes. So it gives you a total of 4 terabytes of space if your developers want to use that much space. And in terms of other hardware, obviously we are talking about compute as well as memory. We provide 5 different configurations options for hardware. And these are basically designed so that we can address your use cases and provide the right type of hardware for the right type of usage. So we do a lot of work to make sure that we have the right set of hardware for the right set of users that you are going to deploy workspaces for. And this list obviously continues increasing. 2 or 3 years ago, this was a list of 3. Now it's a list of 5. Obviously, we're going to continue iterating and keep adding more hardware options as customers are asking us about more options, and as customers are deploying workspaces to more new and new user types. So here there's a list of different typical usage that you would associate with each of the hardware option, as well as the use cases. Since today we are talking mostly about developers, our customers mostly use Power and Power Pro for their developers and analysts. These are 4 CPU and 8 CPU machines and 16 and 32 gig memories, respectively. But that doesn't mean that the other ones are not being used by developers. In a lot of cases, our value and standard bundle is very, very popular as a testbed environment. So you have a developer who himself or herself is coding on Power or Power Pro, but they want to run some compile job or some test on their value for their website or application, and they can easily do it on that. Obviously, the benefit is that value is super cheap, so it's very low cost compared to Power and Power Pro. And because there's no active user on these test environments, you can literally just run the test and forget about it. It's going to finish, and you can go or your developer can go take a look at the results. So really, really economical benefit for your users. And then, again, we talked a little bit about that a lot of customers are using Amazon Linux Workspaces for web applications where there's just one single web browser, and their users are really just doing their productivity work through that website, through web applications. So value is also a very good use case for that. So let's jump down into a little bit more details on what we can achieve using Amazon Linux Workspaces. So here we have shown a simple demo environment. This environment is very much similar to what we did earlier in the flowchart that we discussed, where there was an AD connector, where there was Active Directory connecting from your corporate site, as well as workspaces and your VPC. So this is kind of our demo environment that we are going to run the demo on today. So the first part of the demo is that we are going to prepare Linux. What that means is that we are going to prepare our Linux image. So let's jump into that. So here, let's go to the Workspaces service first. So now we are in the Workspaces service. So we'll start with looking at some of the bundles that we have. We already created this just as a test bed. We are also going to first start by launching a workspace. Here we are going to just type in the user. And really, right now, the step we are trying to perform here is what we discussed earlier, where we took a workspace and then we installed a bunch of applications and packages on it in order to create sort of a golden image from it. So this is the step that we are trying to perform through this demo. So here I'm going to add the user. I'm going to go to the next screen. I'm going to select a bundle that we just covered that is more suitable for this my custom bundle that I'm trying to create here for my developers. I'm going to select the storage size that I need, and then I'm going to move forward. Here I can decide whether I want this to be encrypted or not encrypted. If I want it to be encrypted, I can put a name for the key, or I can also put tags on this machine. In this case, I want to tag it, probably you would like to tag it as an image prep machine. So we went through that. Now we're going to wait for the workspace to launch. And once this workspace is launched, I'm going to connect to this workspace using the WorkSpaces client. You can download this client from our public website. Further URL is available on our public documentation. So here's the first look into Amazon Linux Workspaces. This is what you will get once you log into your workspace for the first time. So I'm going to open the terminal here. I'm going to take a few steps to install some of the packages that we discussed earlier. So it's always a good practice to, first of all, run update on your workspace, even though like we mentioned, we automatically update a workspace during the provisioning step. But here I'm going to do some housekeeping and run updates, install a couple of packages that are pretty self-explanatory. And you can use, based on your developer requirements, you can install the packages that you like the most. Okay, so once you're done with that, what you will do is that you will create a custom image from it. But let's take a look at the summary of what we achieved in this demo. So first of all, what we did is that we ran a yum update. And then what we did is that we installed Apple. So Apple, is very famous enterprise Linux repository. So Amazon Linux Extras has that repository. So we will install Apple. Then finally, one of the key things that you should be able to do is modify the PC over IP configuration file. So just to give a little bit of background, PC over IP is the streaming protocol that Amazon Linux Workspaces use currently, and this protocol has the ability to control certain settings. For example, do you want to restrict your clipboard? Do you want to restrict certain channels for streaming, and so on. So we just took a simple example here just to show you that this is the PC over IP configuration file that you can modify. And really, it's a conf file, so you can open it in any of the text editor that you want, and you can search, the web to find PC over IP Linux configuration settings, and that will tell you exactly what the settings are there that you can toggle. Even the configuration file has all that detailed in a README. So this is really you have updated the image, you have installed some of the applications that you need, and you have edited your configuration file for your specific users. One of the benefit here is, for example, you don't want to give copy paste or clipboard permissions to your offshore contractors, for example. So this is the file that you will edit to block that access. Then let's go to the next step. As we discussed earlier, now we have our workspace ready. It's our image machine. It has all the settings and installation there. Now I want to create a custom bundle from it. Again, we didn't do these steps in this demo here, but you are free to install or add any packages and applications that your developers require. So in this case, just in the previous step where we were running these yum updates and we were installing Apple, you can install, for example, OpenJDK, Eclipse, and some of these things. AWS CLI already comes prepackaged into Amazon Linux Workspaces, but then you can install Eclipse, Atom, Visual Studio Code, and so on, whichever your developers require. And then obviously once you have this whole image ready that your developers would like, you can then create the Java developer customer bundle. So the Java bundle is the one that we earlier reviewed in a list of custom bundles. Again, it's really up to your development requirements, how you want to create this mix of applications in your image. So let's take a quick look of how to do that. So here I'm logged in back into my workspaces, and I'm going to try to install all of these applications that we just discussed. So I'm going to go to some of the websites. For example, I'll go to Eclipse, Eclipse for AWS. I'll download it. It's really, really simple. Just like you would install on any other Linux machine, or maybe even easier here because we have a nice UI layer to kind of do this from a UI perspective. So here I've opened the Eclipse installer. I've taken the Java environment. So I'm going to use the Java specific Eclipse just to kind of install it fully. So once the Eclipse installation is complete, we can launch it. We can make some settings in here. What we are really trying to achieve here is one of the biggest benefit with Amazon Linux Workspaces is because your workspace is sitting in the AWS cloud. At the same time, your Amazon other AWS artifacts or other AWS infrastructure artifacts like EC2, S3, and all of those elements are also sitting in the AWS cloud. So what you can do, or what you can achieve, is that you have a really high speed of development and compilation between a workspace and an application on EC2, for example. So what we are doing here is we are trying to configure AWS Toolkit for Eclipse. And what that will do is that now this development box that you have prepared, or this development image that you have prepared for Amazon Linux Workspaces, it is going to be able to talk to your EC2 instances or S3 instances, all of the AWS artifacts that are part of the credentials that you have configured in this AWS toolkit for Eclipse. So the net effect that you're achieving is that in the past, when you have an EC2 instance running in AWS Cloud, you are and your developer is using a laptop, your developer is really dependent on the bottleneck speed of the internet or Wi-Fi that is on the laptop to be able to push that compile job to the EC2 instance. So obviously it's not very fast. In this case, because your access device is just accessing the Workspace's desktop, so we don't have that bottleneck there. where your Amazon Linux Workspaces desktop is talking to EC2, and they're sitting really close to each other in the cloud. So you're able to achieve really high speed compilation and those kind of jobs. Okay, so here what we have done is that exactly what we explained. So now your Eclipse is kind of ready to be hooked into your AWS infrastructure artifact. So you can basically, just like we explained that you can access your EC2 instance, you can directly push code from Eclipse compiler directly to your AWS artifacts. And here, what we are going to do, now that my machine is ready with all of these settings that we talked about, now I'm creating a custom image from that Workspaces machine. And it's a really simple step, as you can see. You can also use our API if needed. But here you have like the you have created an image from that workspace, and this is going to become a part of your bundle. So again, custom bundle is consisting of the OS as well as the image, which is what we created here, as well as the hardware that you want that bundle to have. So you can put the compute type that you need, you can put the memory here that you need. Now, what happens is that now that you have this bundle developed for yourself, like we covered earlier, you can launch many workspaces from it. And here we're going to go into the same, create workspaces, launch flow. And here you're going to be able to see that the bundle that you just created is now available here for you to launch workspaces from. Okay, now the final piece that we're going to cover here is the customization of the desktop environment. So now that your developers are getting the specific type of hardware that they need, they're getting the Amazon Linux environment. Obviously, they are able to access their choice of IDE, the packages that they want. You have also been able to hook it to AWS resources. You can really configure it to hook into any of your AWS resources or use other IDEs. We just used the example of Eclipse. Now the final piece is that how do you customize the desktop environment? So Amazon Linux Workspaces has by default Mate desktop environment, and Mate is basically a fork of, so to speak. It continues the GNOME 2 desktop environment. The GNOME 2 desktop environment is this very simple and easy to use desktop environment. And our goal with Amazon Linux Workspaces default desktop was to make it very simple, modern, and elegant to use. So you'll see that there's a lot of simplicity to this desktop. Some of the key things that customers generally use it for is that they want to, for example, brand their desktop. They want to be able to prevent users from, getting rid of that branding, for example, and many other things. So it's fully customizable, just like all of the Linux pieces in the desktop. So you can actively be able to configure the certain settings of the desktop that you want your users to see. So here we're going to do an example of what we can achieve by some of those desktop customization. So as we discussed, here I'm just trying to, modify the wallpapers. There's, certain wallpapers that are automatically included. There's the default workspaces wallpaper that we have created that is here. You can really use any wallpaper that you want, but this is kind of the desktop customization that we were just discussing. You can also change icon sets, you can change themes, as well as you can enforce certain settings that you don't want your users to change. In this case, what we are trying to do here is that we're trying to prevent users from changing the desktop wallpaper. Obviously, your users should be able to change the desktop wallpaper, but here we are just giving you an example of how you can prevent your users from modifying any setting that you have in your desktop. So this is what we achieved in this demo. We already discussed about how Mate desktop environment can be used to apply defaults. There are certain settings that are available in G settings. You can really, modify the deconf schema. You can prevent file changes using those default deconf schema. There's a command that you can use to ensure that all the settings are updated. Again, this is a very simple example that we're using here. There's a lot of material online. If you want to, take a look, you can search for, how to modify G settings, how to enforce certain settings, and so on, because GNOME 2 and Mate are pretty popular and widely used desktop environments. Now let's talk a little bit about scaling. So as we discussed in the beginning of our talk, we were looking at first, how do we prepare workspaces for developers? How do we provide this a specific type of workspaces to specific type of developer users? And then we talked about that we are going to look at how can we operate at scale. So when we are talking about scale, you might have 2,000, 10,000, 20,000, a large number of Amazon workspaces running that your developers are using. So obviously the two key things you want to achieve is that they're securely updated always. Now, because Amazon Workspaces is a fully managed service, we keep those updates running. So all of your workspaces automatically get those updates, specifically in the case of Amazon Linux Workspaces. But the second thing you want to also enforce or offer is configuration management, which is some things that we discussed right now. We discussed about PC over IP configuration settings. We discussed about your desktop configuration settings, and so on. We discussed certain things about the configuration. So AWS Opsworks is a fully managed service that provides configuration management services for DevOps. So here, what you can do is that you can hook your Amazon Linux workspaces into your AWS Opsworks servers using either Chef or Puppet. And then you can use AWS Opsworks to really manage all of your Amazon Linux workspaces configuration. So in this model, as you can see that you literally have nothing to worry about in terms of running a hardware server in your IT or on premises to be able to manage these Amazon Linux workspaces desktops. You can use both AWS services, Amazon Workspaces, and Amazon or AWS Opsworks to perform that configuration management. Chef and Puppet are some of the most popular tools that are used in the industry for management of Linux desktops. So that's why AWS Opsworks has been working with Chef and Puppet to be able to provide that functionality. So most of the functionality that you will see in AWS Opsworks, can be applied via using Chef and Puppet to Amazon Linux workspaces. There's actually a couple of talks. If you just search AWS Tech Talks, there's specific elaborated tech talks about how you can use AWS Opsworks with Amazon Linux workspaces, both for Chef and Puppet. So that's a high-level view. Now let's look at a little bit deeper detail on how AWS Opsworks hooks into Amazon Linux workspaces. So first of all, AWS Opsworks instance level is a combination of packages, files, config. These are the things that you are really trying to manage on your Amazon Linux Workspaces desktops. So you want to manage the type of packages or applications that are there. You want to be able to remove or delete files if that is something that you want to do to increase security of your Amazon Linux Workspaces. And finally, you have the configuration management piece of it. So you want to make sure that if you set a PC over IP configuration of disabling clipboard, that stays there. So you can't, your user cannot go and modify that configuration to be something else. One of the reasons that they would be able to do that is pretty common that, many developers require root access to be able to perform a lot of their work. We generally recommend a best practice that you don't give blanket root access to your developers, rather provide specific command level access for sudo so they can run the specific commands that they require rather than have blanket root access. However, in some cases, if you are running some kernel level development or hardware development, your developers might need full root level access. So in that case, this is a very helpful tool to make sure that the configurations are in the state that you expect them to be at any given time. So effectively, the talks that I talked about, again, they elaborate a little bit more on this slide and the next one, where it's about integrating the Puppet node using AWS Opsworks with Amazon Linux Workspaces. So there's 3 key steps to doing that, 4, and these 4 steps are, they're very simple. They don't take a lot of time to do it. It's quite simple to implement them, and using some of the talks that I talked about regarding AWS Opsworks with Amazon Linux Workspaces, you will be able to follow through those on a step-by-step level to actually implement it on ground. So real quick, we can go through these steps. First, obviously, is that you require a signed certificate, so that your Puppet node can recognize your Amazon Linux workspace. And then it has the ability to basically associate with that node, so that your Puppet knows all of your Amazon Linux workspaces. And then obviously your node is then responsible. Your Puppet server is then responsible for managing these nodes, which are Amazon Linux workspaces. And then it can also generate results from, for example, querying. So all in all, once this step is done, your Puppet node is able to maintain a certain configuration. It's able to deploy certain configurations to your node, such as package installation and application installation. And then it is able to generate results as part of any querying. So some enterprise customers run OS querying on their Amazon Linux Workspaces desktop. This will provide results of that query back to your Puppet server, so you can assess, how many of your Amazon Linux workspaces are in healthy state from your security and control perspective, and how many needs a configuration change. So this is kind of a more deeper view into exactly what we discussed. So the deeper view, what is happening here is that once the associate node step is happening, you are basically establishing trust with your AWS Opsworks, Chef, or Puppet server. And once that trust is established between these 2 factors, then you are able to do all of the configuration management and other monitoring activities that we discussed. So again, nodes here are Amazon Linux workspaces. Chef and Puppet servers here are hosted in AWS Opsworks. And once this linking is established, you can perform monitoring of your nodes. For example, one of the very famous use case is with CIS benchmark monitoring. So you are able to monitor those CIS benchmarks of your Amazon Linux workspaces. So with that, we will close our talk today, and let's do a quick recap of what we learned today. So first of all, today we learned what are Amazon Linux workspaces, what benefits they provide to our enterprise customers, where are they deployed in terms of different type of developer use cases. We also discussed about how you can use Amazon Linux workspaces bundles to really focus on your different developer populations. We took the example of Java, but obviously you can take that and replicate it across for different developer use cases. We also today reviewed what type of specific hardware options are available for you to create those Amazon Linux workspaces bundles. So really had a quite good understanding and insight into Amazon Linux workspaces. Second, what we did today is we looked at Amazon Linux workspaces in action. We were able to log into it. We were able to modify it. We did prepare our image from the Amazon Linux workspace that we created. And ultimately, we were able to create a bundle that we can replicate at scale. And finally, what we learned today is that how do you administer and manage your Amazon Linux workspaces using Opsworks at scale. And with that, we will conclude our virtual session for today. First of all, thank you for joining me today here and learn about Amazon Linux workspaces. I hope you are able to take these learnings and apply them directly into your enterprise workloads and deploy Amazon Linux workspaces for your developers. My name is Hassan, and in any case, if you want to reach out to me, my contact information is available on this slide. Thank you.